Hi children, welcome back again to Science Capsule, a perfect self-learning tool. So I am back again with some most important stuff for class 10. So a series of episodes are going to be recorded so that you will have enough grip on a most important chapter, that is electricity. As far as this chapter is concerned, theoretical portion is on one side and a numerical portion is on another side. Mostly the students run away from the numerical problems since they do not understand how to solve numerical problems and they find it very difficult. So in order to make the understanding very easier, in order to make the concept very easier, I am going to make a series of episodes so that you will have mastery in solving the numerical problems. So trust me, just you keep on following these videos step by step. I'm going to make each and every episode in a stepwise manner so that once we complete the episodes, then we will be having a crystal clear idea about how to solve the numerical problems, right? So in today's episode, we are going to see the basics of doing numerical problems. So this video is going to be very crucial and important. So don't miss even a second, right? So if you are not subscribed this channel, then you can subscribe this channel, and after watching the video, if you find it useful, then you can share it as much as possible so that your friends can also make use of it. Okay, so without making much delay, let's start today's episode. So as far as this chapter is concerned, we begin with the two important concepts. One is what is electric current and what are the associated terms. What is potential difference and associated terms. About potential difference and electric current, a separate detailed video has already been uploaded in this channel. If you have not watched those videos, then you will find it in the I button, and I'll also provide in the description. From the description you can watch all those videos too. Once you have the basic or the theoretical concept about electric current and the potential difference, then you will find it very easy to understand the basics. So as far as electric current is concerned, we have discussed that it is the amount of electric charges, we call it, isn't it? Charges flow in a conductor in a unit time, in a particular area in a unit time. So mathematically, how we express it? We express it as I is equal to Q by T, isn't it? So this is already given in your textbook and we have already discussed. So here I is the symbol of current, Q is the symbol of charge, T is the symbol of time. So this we have already discussed. If you substitute the SI unit of charge, we know that SI unit of charge is coulomb and it is represented by the symbol C. What is the value of C and all we have discussed, you can watch in those videos. Time, the SI unit of time is second and it is represented by the letter small s. And if 1 coulomb of charge is flowing in a conductor in 1 second, then we call it as 1 ampere of current. So this you should know. So SI unit of current is ampere and it is represented by the symbol A. So this you should know, right? Okay. So here 1 ampere, and this is the larger current, in the smaller current also exists. So smaller current is measured in milliampere and microampere. About the conversion and all already given in the previous video available in my channel, then you can watch those videos to understand the conversion and all. I'm not going to waste time in explaining all these things. And one more thing what we have discussed was potential difference. So V is equal to W by Q, which means in order to carry a unit positive charge or a charge from one point to another, whatever the work done, that will give you the potential difference. So about potential difference, what exactly the potential difference is, a separate video is already uploaded, so that also you can watch. So about electric current and potential difference, you can understand the theoretical concept. So here work done, the SI unit of work done is joule and it is represented by the letter capital J. We know that the SI unit of Q is, that is charge, it is represented by C, and if 1 joule of work is done in carrying 1 coulomb of charge, then the potential difference would be 1 volt. So here V is the SI unit of potential difference, which is voltage or volt. Got it? So now let us understand solving numerical problems from the basics, step by step manner, so that you can solve even difficult numerical problems too. So on the basis of these two informations, let us do some of the numerical problems which are given in your textbook. So if you look at your textbook, one of the easiest numerical problem which is given, so look at the screen, dear children. See here, a current of 0.5 ampere is drawn by a filament of an electric bulb for 10 minutes. Find the amount of electric charge that flows through the circuit. So this is the question as you can look at the screen. Here you see, in order to solve any numerical problem, what you have to do is, first you have to identify the given quantities. What are the quantities given? If you could write it properly, then it's a bit pretty easy to solve the numerical problem. So let us find out how to extract the given quantities from the question. So see here, there are various ways. Here you see a current of 0.5 ampere. So here a current of 0.5 ampere is given, right? So here ampere is the value of current. So current is given. So here the given quantity I is equal to 0.5 ampere. Isn't it? Current is given. Then second, what is given here? Filament of an electric bulb for 10 minutes. What is 10 minutes? Minutes is the time. So time is given. Time is equal to 10 minutes. Right? So according to the question, find the amount of electric charge. Electric charge means here it is Q, electric charge. Q you have to find. See here, from the question we have easily extracted the given quantities. So current is given and the time is given. So two quantities we have found out, third quantity we have to find. Now in order to solve a numerical problem, what are all the quantities in the current formula is given? See here, current I is there, Q is there, T. Now if any of the two quantities are available in the question, then the third quantity can be found out very easily by rearranging the equation, right? So see here, current is given, time is given, Q. So by rearranging this equation you can solve. How to solve? That we will see. Now one more important thing what you have to see is, as far as the equation is concerned, I have written the SI unit. You see here, you should not change the SI unit. As far as the charge is expressed in coulomb, time must be expressed in second. If not expressed in second, then you have to convert it into second. See here how it can be. Here if it is not in ampere, you have to convert it into ampere. So this is the logic where you have to apply. So see here, current is in ampere, so SI unit of current is ampere, so ampere is there, so no need to change this quantity. But if you see time is expressed in second, right? So it should be converted into second. So here it is given in minute. We know that 1 minute is equal to 60 seconds. So 10 minutes is equal to 10 into 60, isn't it? So this would be 600 seconds. So see here, time expressed in second, time current is in ampere. So we know that the formula I is equal to Q by T. This you have to write. So from this equation, if T goes this side, the equation can be rearranged easily, right? So here Q is equal to I into T, right? Now if you could rearrange the equation properly, then the next only thing left is substitute the values and solve it. So it's very simple, right? So here Q is equal to I is 0.5 multiplied by time is 600 seconds. So what would be the answer here? So see here, 600 second, half of 600 second would be 300 second. So here 300 coulomb of charge. This would be the answer. How easy, right? So in this question, what we have did, we have extracted the quantities from the given quantities from the question. Once we extracted, then we found the equation. Upon rearranging this equation, we substituted the value in one step. We solved the numerical problem. So this is how we can solve the numerical problem very easily. So as far as current is concerned, only formula we have, that is I is equal to Q by T. So on the basis of that, whatever the question that comes, that can be solved by using I is equal to Q by T, isn't it? Now there are some questions maybe asked in the CBSE examination based on potential difference. So we know that V is equal to, what's that? It is W by Q. So this you have to remember, you by heart it, which will help you to solve the numerical problem. So on the basis of this, a question is given in your textbook. Here on the screen you can see a question. How much work is done in moving a charge of 2 coulomb across 2 points having a potential difference 12 volt? So let's see how to solve. The primary thing, the first thing what we have to do is we have to extract the given quantities from the question. So in this question, what are the quantities given? The given quantities are 2 coulomb across 2 points. So coulomb is the SI unit of charge, isn't it? So here in this question, charge is given. So the first quantity what we can find in the question is charge. Charge is 2 coulomb, isn't it? Now the second quantity is also given, that is having a potential difference 12 volt. Whenever you find V, that is potential difference, V that is volt, which is the SI unit of potential difference, so straight away you can note it the value. So without reading the question also, you can easily extract the quantities by looking at the SI unit, isn't it? Okay, so here potential difference is given, V is equal to how much? It is 12 volt, right? So 2 quantities are given, you see here, this is the equation. When we talk about potential difference, this is the equation, right? So in this question, Q is given, so Q is there, volt is given, yes. Now what we supposed to find out? Here, how much work is done? That is work done we have to find. W is equal to question mark. We have to find. So can you find it? It's very easy, because as I told you earlier, if 2 of the quantities are known, then third quantity is very easy. So we have to rearrange this, because here W we have to find, work done we have to find, right? So work done would be, here Q goes this side, then upon swapping, upon rearranging, what we will get? Here V into Q. So we have both the values of V and Q. Substitute the value of V, that is here 12 volt, multiplied by Q is 2 coulomb, and we know that the SI unit of work done is joule. So no need to by heart all these things, just you solve it. 2 into 12 is 24. So what would be the SI unit? We know that the SI unit of work done is a joule. Straight away, how easy, right? So what we have done in this question, we have just extracted the given quantities from the question and substituted the values. So for that, in order to substitute the values, what we need to know? We should know the formula. So 2 formulae we have used. One is I is equal to Q by T for current, and the potential difference V is equal to W by Q. Got it? So on the basis of this, let us solve another unsolved exercise which is given in a textbook. So let us solve that also within 1 or 2 minutes, right? So look at the screen again for the third unsolved question that is available in your textbook. Look at the screen. How much energy is given to each coulomb of charge passing through a 6 volt battery? Again the same thing. So can you do? Just I initiate how to do, then the rest all the things you can do, and you can mention the answer in the comment section. Alright? Okay. So see here, according to the question, what are all the quantities given? Here, how much energy is given to each coulomb of charge? Each coulomb is the SI unit of charge. So each means 1. So here charge is equal to 1 coulomb, right? Then passing through a 6 volt battery. Here volt is the SI unit of potential difference. So here what we have potential difference? V, that is V is equal to how much? 6 volt. What we have to find? See here, how much energy is given. So what does this energy? And see here, Q is there, V is there. Somewhat this relates to the equation. What is that? Potential V is equal to work done by Q, isn't it? Now see here, Q is there, V is there. But according to the question, from the question, what we have to find? We have to find the energy. Here work done is not given. You should know the SI unit of work done is joule. Joule is nothing. It is energy, right? So in the question, if they ask to find work done or to find the energy, both are the same, both refers to the same quantity, isn't it? Now here in the question, they are not asked to find the work done, they asked to find out the energy. So energy, the SI unit of energy is joule, which is the SI unit of work done. So here, according to the question, we have to find work done. So how can we find? So here V is equal to W by Q. So again we have to find the work done, right? So we know upon rearranging this equation, W is equal to V into Q. We have the values. Now substitute these quantities in this equation and find out the answer. Then you can post the answer in the comment section. Let us see how many of you could do, how many of you could solve this numerical problem. So dear students, that's all we have in today's episode. I hope you found the numerical problems pretty easy to solve. So based on this, we will solve some more so-called difficult numerical problems, which we will see in the next episode.